All right, so I see a few people still joining in here. We'll just give them a couple more seconds to fully join in. Just so everyone is aware, I will be muting everyone just to eliminate any extraneous noise that we might be getting on the phone. And if you do have questions, please feel free to ask questions in the chat box, in your GoToMeeting dialog box that you should see, and I will definitely be able to see those and address those accordingly. Okay. Okay, so thank you again for everyone for attending. This is part of our Did You Know webinar series that we've been hosting, just to inform you a little bit more about what Mentor Graphics solutions can provide for you and how they can help you through your electronic design process. So today we are going to be tackling Rigid Flex PCB design and how we can easily solve some of the challenges that are associated with those types of designs. We're just going to be learning some new techniques that will help create a Flex PCB a little bit faster, some common challenges that we see with Flex design, and ultimately how to simplify this design process. So if you're not familiar with Oasis Sales and Mentor Graphics, we do provide solutions for your entire design process, from the initial design, schematic design, layout design, mechanical design. We offer those types of solutions. Also, we are very powerful in the simulation and analysis domain as well, through hyperlinks and Valor and PI, if you're familiar with any of those. And we also ultimately provide solutions for cost savings to help you eliminate unnecessary design time and respins of your designs. Just a little bit more about Oasis Sales, if you're unfamiliar with us. We have been a Mentor Graphics, now a Siemens company. We've been a premier partner for over 16 years, so we've worked very closely with Mentor Graphics in order to learn more about their tools and how to best serve our customers. Okay, so we are spread out pretty much all over the Midwest territory of the United States. Here's a quick breakdown map of our area of where we're located. So you'll see we cover the Northwest, the Midwest, Southwest a little bit, and then even the Great Lakes states. And if you are in the Northeast half of, or the eastern side of the United States, you work with a reseller named TriLogic, who we've kind of collaborated a little bit with on our webinars lately, just to make sure that we can get the useful information to everyone that would like to see it. So we do host webinars on a pretty frequent basis. If you're not familiar with our website already, it's just www.oasissales.com down there at the bottom, and it contains a webinar page where all of our past archived webinars are available to view. So we have got a lot of great content on there, some in the PAD space, some in the hyperlink space, and then also some in the Xpedition and PADS professional space. So if you're looking for a little bit more information on a certain area, please feel free to check out our website, and then also our YouTube channel, where I'm currently recording this session, this webinar here, and it will be posted up on YouTube afterward, just to so you can watch that again if you'd like. Here's my contact information if you guys want to take a quick screenshot of that or write it down real quick. Again, my name is Kyle Lake. I'm an application engineer with Oasis Sales. I've been with Oasis for a little over 2 years, and I actually was with Mentor Graphics beforehand. So I've worked a lot in the board system division with PADS Professional, PADS, and Xpedition space. So please feel free to give me a call or shoot me an email if you would have any more information after today. I'm just going to throw this out there. I am currently planning on doing my next webinar on January 18th. It's going to be, did you know you can efficiently screen for SI, PI, and EMI issues, definitely more on the simulation side, covering our Hyperlinks family of tools. And that's going to be at the same time, so 9:30 Pacific on January 18th, if that sounds interesting. Just so you guys know, during the webinar, if you do have questions, you should see a box very similar to what is shown on the screen. And if you hit on the chat tab, you'll be able to ask a question, and I'll be able to see that and answer that accordingly. Okay, so let's just hop right into it. So this is just a slide that's really giving us an overview of what Mentor Graphics can offer all of us in the electronic design space. So Xpedition and pads are two very capable layout tools. Xpedition is definitely more of an enterprise level tool that allows for greater collaboration between design teams, a little bit more strict data management, and some very powerful layout and routing capabilities. Pads is more of a desktop-based solution for smaller design teams, but yet a very capable tool in itself. It has gotten a lot of great technology from the Xpedition space, and vice versa. Actually, some good ideas from the pad space has been brought into the Xpedition space as well. So if you're familiar with Hyperlinks, it's a very strong competitor in the PCB simulation, analysis, and verification space within the electronic design automation industry. It is used for signal integrity analysis, power integrity analysis, as well as EMI checking. And then Valor is kind of a PCB assembly, test, and manufacturing checker for post-design or even mid-design for assembly check, as well as fabrication checks. Very powerful tool as well. So that's kind of the family of tools that Mentor Graphics offers and that we as Oasis Sales are able to support for you. Just a little bit about how the PCB system is exponentially increasing the design of PCBs. So on the graph on the right is actually kind of showing the average leads per square inch is continually almost an exponential factor increasing over the years, while the actual size of the board, the area in this brown line at the bottom, is actually decreasing. So that just means that our boards are getting smaller, they're getting more dense, more components on them, which can definitely lead to certain issues, design issues that you might have. One of those major issues is possibly designing Flex, which we will be talking about today. So obviously Flex has some advantages. We can pack more on there, have it in a smaller form factor due to the fact that we are actually able to fold up the design and do some very interesting things with the board outline and not having a completely square or rigid factor. And this board on the left is actually part of our Technology Leadership Award that Mentor does. It was designed actually in pads, and it's just highlighting some advanced technology that you can use within some of Mentor's products. And this is actually a NASA design that is used in this particular enclosure here. Okay, so I'm not sure of the background on a lot of the attendees today. Some of you might be currently doing a lot of Flex designs. Some of you might just be interested in the technology, and then some of you might be hopping into it soon. So I want to kind of give a low-level discussion on why we might want to decide to use Flex. It is definitely an enabling technology. It's very widely used in the industry, which allows for more in a smaller package and a cheaper option than doing some other space-saving technology that you have the option to do. We have some increased integration by integrating cabling directly into the PCB design, so that eliminates going out and finding vendors for different cabling and getting that into your actual PCB design. Everything is handled from schematic to layout for the entire Rigid Flex design. Of course, we've got 3D folding to fit the actual product. This gives you a lot more leeway when it comes to fitting in the enclosure and making your actual circuit and layout work in that enclosure. And then Flex actually is very robust. It is very electromechanical reliable. It allows for dynamic bending. The actual bendable area, the flex area, can be bended at extreme angles if necessary, and it can withstand quite a lot of bend and unbend processes. Very vibration and shock tolerable, and it is heat resistant. Okay. And again, please, if you have any questions, just type that in the chat box and I'll get right to those. So this is just a small example of some challenges of PCB design from Rigid Flex. So one of the most difficult things with Rigid Flex in a lot of design tools is how to actually handle the stack up of the rigid flex, because there's going to be a different stack up depending on if you're on different sections of the rigid board. And of course, we're going to have different sections of stack up in the actual flex circuitry as well. So that can cause some major issues, and I'll show that how Xpedition is able to really make this a very, very simple process to understand a master stack up and assign those accordingly. Some cover layers, stiffeners, and adhesives. These can all be kind of confusing as to when and why they are used. So this is something that you have to be cognizant of and be kind of well informed on actually the flex technology in order to make a good decision and a well-educated decision in where to use those. Bending and folding control, curve routing, those are all necessary within the flex design. Plane fill, that can be a challenge as well, because if you're trying to have planes in the flex portion of the board, that can cause some major manufacturing issues, and we'll talk about how Xpedition can achieve those. And then also we've got a 3D aspect of that. We'll show that in Xpedition, an actual 3D representation of a flex board, and then some DRC signal and power integrity and the actual output of the flex design. Just a quick basics on some flex layers if you're not familiar with these terms. Cover layers, basically a protective coating on the flex layers. This does have to be built into the library part, but again, Xpedition has great DRC rules on this and ensures that all your parts are set up correctly and will notify you of any errors if you're missing any cover layers on your component pads. Bend areas, pretty easy to understand. That's the actual area on the flex circuitry that is going to be bending back and forth, and we can adjust those and see how that's going to affect the actual bending in real time. And then stiffeners is actually just a little bit of rigid piece that's bonded to the flex circuit to make it a little bit more rigid in the areas. And that can be very important to use in certain areas on your flex design. Okay, so one of the first design challenges that I was talking about is the actual stack up of the board. This can be a major challenge because you have to define a master stack up first. And this is how Xpedition actually really simplifies this process. You'll only define one stack up, and then you'll be able to define that stack up on a board outline basis. So when you create a board or a project in Xpedition layout, you're actually able to create multiple board outlines. So this picture on the bottom right will actually show that we have 5 different board outlines in this design. Okay, why this is pretty powerful is because now on a board outline by outline basis, we're actually able to go in and assign the stack up on an outline by outline basis. Very simple, very easy to understand, and we can actually view how that stack up is defined for that particular board area. And due to the fact that that outline is actually defined on the board area, when you change the outline shape or where it's located or anything like that, the stack up does not require to be changed. So it's a very, it changes with the board outline, and it's not a static board outline. So it's very simple to make changes after you've defined the master stack up. Okay, and up here in this top picture, we'll actually see how kind of the master stack up is defined. It's got a 6-layer board going to a 4-layer board through a 2-layer flex zone, and you can kind of see how our stack up is defined, and on those different layers, only certain of that stack up on the right-hand side apply to those certain areas. So I just got a question from Bob. Hi, Bob. He's asking if Xpedition, so this is an Xpedition webinar. Yes, it is. Is this technology, as in rigid flex design, is this available in pads? So many customers do design our rigid flex design within pads. It is definitely possible, and there are going to be some new features coming down into pads to make that a little bit simpler. But this, the features that I'm showing here are going to only be available in the Xpedition space right now. So I'm sure in the future we will have a webinar solely based on pads just to show you the functionality in there, but this is kind of on the Xpedition and the pads professional side of things, showing the Flex here. But at least the information is relevant to the technology at least. All right, so another design challenge that we definitely run into within the Flex design is how to achieve routing in a quick and good fashion in the Flex design, going from rigid to Flex. And Xpedition is very, very powerful routing environment. It has both interactive tools as well as auto routing tools that can actually route for you in the rigid Flex areas. So with our interactive tools, you can plow single or multiple traces at once with 45-degree angles or curves, and curve routing is very powerful and easy to use with an Xpedition that can be leveraged for your Flex design. And there's an automatic way to convert 90-degree angles and 45 corners to actual curve traces. And then if you're not familiar with Xpedition, there are ways to do a sketch router within the rigid Flex. Sketch router is a kind of a interactive auto routing, we like to call it, and it does a very good job of completing traces very rapidly for you. So another design challenge within rigid Flex design is actually doing design rule checking on your rigid Flex design. Some examples of design rules that we have built into the tool just to make sure that your board is both manufacturable as well as assemblable is components too close to a bend, via holes too close to a bend, missing cover layer pads like I said earlier, and then too sharp of bend radiuses with respect to the board thickness. So it'll actually take into effect the thickness of your Flex design and make sure that the bend radius does not will not cause an issue there. So there is a real-time DRC that you can enable that will not allow you to break our design rules. And then also there's a way to check after routing if you're one of those kinds of people that enjoys routing with the DRC off, and then you can do a batch DRC on those rules afterward. Okay, so if there's no questions on kind of what I covered there, just a general overview of what Xpedition can do and some of our challenges associated with Flex design, I'm going to actually go ahead and hop into Xpedition. And here we can see I have a fairly straightforward Flex design here in the 2D space right now. So again, this is Xpedition layout, and this is on the current version VX 2.2, and that's the most current version to date. So the first thing I want to address is that we will actually be able to kind of see different board outlines. So we have different board outlines here defined in red, and that will allow us again to define the stack up on a board outline by board outline basis. So if I want to first go into the stack up editor, this will actually show us our master stack up for our entire design. Okay, so you'll see here that it's actually an 8-layer board, but there are a lot of non-electrical layers that are necessary to be built in, like these cover layers, adhesive layers, flex cores, adhesives. So these are all drawn proportionately on the right-hand side and defined here on the left-hand side. So this is what we're going to define as our master stack up, and it actually will give us our total thickness of the entire stack up design and allow us again to go back into design and define our different board outlines to this master stack up. Okay. If you want, it's very easy to manipulate this. You can go ahead and insert above or below signal planes, solid plane, split mix signal. If you're unfamiliar with this stack up editor, very simple to use and pretty powerful. Okay. So going back into the design, actually, we've got these different board outlines, and if I double click on this, we'll see that it's a board outline of a type Flex. Okay, so we've named this particular board outline Flex Cable 1, and we'll see that the stack up layers are custom. if I click on the three dots here, that'll just actually open up a dialog box, again showing our master stackup. So you'll see here with checkboxes that we can go ahead and set which layers we want for that particular board outline. I can click on display included layers only, and that'll only show the layers that we have on this particular board outline that we have selected here. Okay. What makes this really easy and powerful is if I actually click on the view stackup, this will just give us that same window that we had in the stackup editor, showing us kind of a physical cross section of the stackup, only associated with that board outline. So very easy to understand which layers that particular area of the Flex design is using. So this is a Flex. If I actually go ahead and hop into, this is a rigid board, I can view the stackup for that rigid board, and you'll see that it's using almost all of the stackup layers that we've defined in our master stackup. Okay, so I see another question from Randy Shoemaker. Hi, Randy. And his question is this not available in Xpedition VX 1.2? So like I said, this is VX 2.2, the most current version. This functionality that I'm showing right here, this is available in Xpedition VX 1.2. This does require an additional option purchase, but in the newer versions, actually, it is included in your licensing. So Randy, if it is possible to move up to the newer version, and then you will have to get a new license, but that's just something that we can do for you. You will have this type of functionality included in there, okay? All right, so we've got our multiple board outlines defined. So you'll see here we have 1, 2, 3, 4, 5, 6 different board outlines defined. And that allows us to, again, define 6 different stackups from that master stackup. So really easy to go and start your design and set up the stackup correctly first. So that's really powerful and important to start off with a correct stackup in the beginning of your design in order to make sure we're off on the right foot. Okay. So the next thing I want to highlight is you'll see these yellow boxes in the actual Flex areas. So what these are actually bend areas that we have defined on those Flex areas. So you'll see that this is a drawn yellow box here, which is our bend area. Okay. And what this allows us to do is basically describe how this Flex is going to be bended, which direction, what angle, and the radius of that bend. Okay. So this is important to do because what we can do within the pads or within the Xpedition environment is actually go ahead and view this in 3D. And let me go ahead and get this side by side. So here we'll actually be able to see the rigid Flex in 3D with the bend areas on. Okay. If you'd like to work with it in just the 2D space type, I can actually go ahead and turn off the Flex bend, so that'll flatten out this entire board, and we'll just be able to have a kind of a bird's eye perspective of the board with all of its actual rigid Flex design in there. Okay, so I'm going to go ahead and turn on that Flex bend again. So this is the 3D environment. Again, this is included with Xpedition earlier or since VX.1. So if you're on an older version than that, you're not going to have this 3D capability. But if you're on a newer version and you haven't seen the 3D capability built within Xpedition, this is exactly what it looks like. Okay, and if you're in the pads realm, like I believe we had Bob Gatz was here, he's in pads. The 3D environment within pads looks very similar to this as well. Okay. So going back to those bend areas, if I have them defined in the 2D space, what I can do here is actually go ahead and edit this bend area. So for example, if I want to change this bend angle from 75 degrees or from 90 degrees to, let's say, 75 degrees, we can actually see in real time this flex design area actually change that bend radius. So I'm going to go ahead and make this maybe a 45 to make it a little bit more drastic, and we should actually see how this in 3D is affected. Okay, so very easy to go ahead and understand how our flex is going to work in 3D, all within the Xpedition environment. Okay. If I actually want to go ahead and just switch this to something very drastic like 10 degrees, you'll see how that is updated in real time. Okay. So within the 3D environment, actually, we do have the ability to import mechanical models as well. So why this can be important with our flex design is you can actually get your mechanical model in, and just to show, these are our different formats that we are able to actually go ahead and import mechanical models as well as component models. You'll see that we do have some component models in 3D mapped as well. These are the different types of files that we are actually able to import. I've worked mostly with STEP and SAT, and those work very well for bringing in mechanical and component models. So what you can do is bring in your enclosure and then fold this all up exactly like how it's going to be in the real environment, the real world, after you've actually created the design, just to make sure that everything is going to fit from a component perspective, from height, as well as actually fitting inside that enclosure with enough bend room so nothing's making too many collisions. Okay. And within the 3D environment, we do have some 3D clearances that we can set from component to component, for example, or from a component to a mechanical object. You can set tolerances in order to flag violations in the 3D space between our rigid flex actually being bended up in the enclosure, or the rigid flex in itself. If it's bending too much, it can flag that as well. Okay. Also in the 3D environment, I just want to highlight a few more things that make rigid flex design easy within a 2D and 3D environment, is the ability to actually do some exporting as well. So what we can do here is go ahead and actually export our 3D mechanical or our 3D layout design in a 3D PDF, which is very helpful, or a STEP or an SAT, which can actually be brought in again to your mechanical team, and then they can place it in their enclosure on the mechanical team side, because I know a lot of design companies like to work it in that type of fashion, and that's very simple to achieve using Xpedition 3D as well. So what I'm going to do, you can do a 3D PDF actually works very well. You can export that, and anyone with Adobe Acrobat is able to open up that view and actually manipulate the design a little bit by turning on or off the different design objects. Okay. All right, so next I want to highlight our actual DRC that can be associated with a rigid flex design. So what I'm going to open up here is our Hazard Explorer. What the Hazard Explorer allows us to do is have real-time feedback on our design against our design rules, okay? And it will actually highlight any areas that come into effect for those DRC rules. So you'll see I have all these different areas. We have online, just like open fan outs, open net lines, all of your normal DRC rules. And then we actually have down here in the bend areas. So you'll see if we have invalid bend areas, that will be flagged in this section. Traces, so we'll see which area location. So this will be the different board outline names that we've defined, and then a slight description on what the issue is. So this is makes it very easy to actually go ahead and identify any issues that you have for your DRC rules within the Rigid Flex design. And if I actually go ahead and select one, it will actually show us which trace that is in the design. Okay. So it'll come in and highlight it for us and allow us to understand where that DRC rule is and how to fix that a little bit easier. Okay, so this is an online DRC, what we can do. And then also we do have the ability to run a batch DRC and output a text document or report just to see those types of batch DRC violations. So we do have one plain violation in the bend area as well. And it looks like it's showing that the crosshatch angle is a little bit off, probably due to the fact that there's only one kind of crosshatch in that plane area. Okay. So far, we have gone ahead and defined a master stackup, drawn our different board outlines for this design, associated all of those board outlines with the stackup that is necessary for it at that point, and then actually gone ahead and ran some DRC and visualized this in 3D. So I think these things in the Rigid Flex space can make it a lot simpler and easy to understand exactly what is happening in your design, and easy enough to go ahead and actually complete the design in Rigid Flex. Okay. So for output capabilities, I'm not sure if anyone's really familiar with ODB++. It has been gaining traction and a lot of popularity in the past few months and years. What it is it's basically one format that contains all of your necessary CAD data to send to your manufacturer, instead of going ahead and creating all of your Gerbers one at a time. So PADS and Xpedition both have the capability of outputting ODB++, and ODB++ is definitely suitable for using or for exporting it from your Rigid Flex designs. So all right. So that was all I was planning on showing today. I hope it helps you at least understand the process a little bit further of Rigid Flex design, and how some of the optimization in Xpedition allows you to set up that design real quickly, visualize exactly what you're doing in the 3D space with that Rigid Flex design and the bend areas, and allow you to export that really easily. So again, this will be posted on our website in our archive webinars if you'd like to view it again. And just again, I wanted to save the date for our next webinar that's happening on Thursday, January 18th. And that's going to be, did you know you can efficiently screen for SI, PI, and EMI issues? And that's going to be covering our hyperlinks family of tools. So if there's no further questions, I haven't seen anything else come in. I'd like to thank you for attending this webinar, and hope everyone has a happy holiday season. Thank you. I'll stay on the line for a little bit further longer if anyone has any questions. All right, so it doesn't look like any other questions are coming in. Oh, actually, I just saw Randy again. Hi, Randy. Can you output flex data with Gerbers and NC drill instead of ODB++? Yes, absolutely. There's no issue with that. I just like to highlight ODB++ because it contains all of the data in basically one package, very simple to understand. And one thing I do like to highlight within the ODB++ output is we actually have the ability to launch the ODB++ inside, and I'll just hit OK. And this will actually allow us to essentially view the Gerbers or the ODB++, the manufacturing data, all right outside of your CAD tool. So I know that's a big issue with outputting Gerbers. You might be a little worried on what's happening, but so to answer your question, Randy, yes, Gerbers are totally still fine to actually output all of your NC drill, your Flex Gerber data. That's totally fine. This is just another way to export your CAD data. All right, and so here's actually the ODB++ output. Again, it just allows us to see our different areas on the board. I really like using this output. Okay, well, if there's no further questions, again, thanks everyone for attending, and I hope you have a good rest of your day.